Okay, we'll explain next sensor. So I hope everyone done with the PIR sensor. Yeah. So what all we have covered? I think I taught potentiometer, servo motor, all right. Then moisture sensor. We did not do simulation, but I hope you understood this. And PIR sensor. So next sensor is a temperature sensor. So similar to the PIR sensor. So this temperature has 3 pins. So this temperature sensor is used to measure the temperature value based on the surrounding environment. So what temperature is there? So that will be captured with the temperature sensor, and the value will be given. Okay. So it we can this is the value will be in the analog value. So this analog value we can convert to Fahrenheit Celsius based on the formula. Okay. So I will just show you how you can connect the temperature sensor. So take one breadboard. Okay, and take temperature sensor. Yeah, so you can find this TMP36. So this is the temperature sensor. Simple connection. So we have 3 pins. One is connected to ground, the other one is VCC, and another one will be connected to the pin. Okay, analog pin. So it is a analog device. So the value will be in the analog. Okay, so the first pin is connected to power supply. The second pin will be connected to analog pin. So we'll connect to A3. And the last pin will be connected to ground. Okay. So just give the ground connection. And power supply. So this is the connection. So cool. I'll explain this code. Yeah. So we are connecting to the temperature pin. So now which pin we are connecting? We are connecting to A3. So we having the pin to A3. Again now serial begin 9600. So what is this? So it is a baud rate. So this through which we can communicate with the Arduino. Okay, serial connection. So this much of bits per second will be communicated with that particular port. We are connecting to the USB. Okay, so that port with this baud rate we can communicate. Next, so we are reading the temperature value. So the value will be in the analog format. Okay, so this is how we are reading. So read, analog read, and the temperature, uh, the pin where we have connected. So I have connected to the A3. So I have initialized to A3. So that value we are converting to the Fahrenheit. Okay, to its temperature. Yeah. So this is the formula to convert the so whatever the value that we have received from the sensor to the Fahrenheit. I think it is degree Celsius. Okay. So this is the formula that is used. So um, how this formula reduced not means it is not required, just how to use this sensor is enough, I guess. So that's the reason I directly given this value. Okay, so we need to multiply with 0.488. Okay, then we can convert this the analog output value to the temperature equivalent in the degree Celsius. Okay, and this is the serial dot print. So it is similar to that of printf, where we are putting the value into this serial port, so the port that we are connected. So we can see the value which is printing on the screen. I will show you how to see that. Yeah, you can just click on the serial monitor. Okay, so this serial monitor, so you can see the temperature value here. Yeah, can click on this in the below window. There is a pop-up, so just click on this. So this serial monitor will appear, and you can change the temperature value. And start. So you can change. You click on the temperature sensor, so you can adjust here the degree Celsius. So you can. I think this is the Fahrenheit. So if you want, you can use the formula to convert degree to Fahrenheit to degree Celsius. Okay. So you can vary this temperature value here. So just left click on the sensor, and you can see there is a bar. So this bar you can change, and different sensor value you can see. Okay, so this is how we can use the temperature sensor. So please take temperature sensor and connect to 3 pins. There is one is source, ground, and another one is analog input. And try this code. Just convert the whatever the value I have given is Fahrenheit. So just convert to degree Celsius and display. I'm just putting this code in the chat. Yes, please try this and display in degree Celsius. So if someone completed, please present your screen. Then we'll go to the ultrasonic sensor. So then I'll explain the next sensor. So please let me know if you are done. This can So if you're done, now we'll go with the ultrasonic sensor. So please let me know if you're done.
Done, sir.
So next, what we have is LDR sensor, ultrasonic sensor. So I will explain this another sensor called as LDR. Yeah. So LDR resistor, also called as photoresistor. So basically, this sensor is used to identify how much light intensity is present. Okay. So based on the light intensity, the value will vary. So it has two terminals. So one is connected to the connection. Yeah. So we have two pins. So one is connected via resistor. Okay. So this will be connected to the ground, and the other one is connected to the power supply. And through resistor, the same pin will be connected to the analog input pin. So we'll be reading this value, and based on the value, we are taking some activity, we are doing some activity. So here is what we are doing. So based on the photoresistor value, so we are turning on the LED or turning off the LED. So if the outside light intensity is more, then we are turning off the LED, and if the outside light intensity is less, we are turning on the LED. Okay, so how this LDR sensor works. So LDR sensor, also called as photon resistor. So what happens? So if there is more light outside, okay, more light outside, this photoresistor will conduct more electricity. Okay, so if there is more light, then it will conduct more electricity. So that time the resistor value will be less. So if there is more intensity of light, then the resistor value is less. And if there is a low intensity outside, then the resistance value will be more. Okay, so it is inversely the resistance value is inversely proportional to the light intensity. Okay, so we'll do this simulation. So you take one resistor and connect to ground, and other one you connect to the source. And the terminal 2 where you are connected to the resistor, you connect to the analog pin for reading the value. So I'm connecting to A1. Okay, yeah. So what connections we are doing? We are connected LED. So we need to connect LED. And another one is connected to digital pin. We'll connect to pin number 13. Pin number 13. And our LDR sensor is connected to pin number A1. You can connect any of the analog pin. So there we have 6 analog pins. So we can connect to any of the analog pin. So I have connected to A1. So we are initializing the LED pin to output and LDR pin to the input. And we are reading the value from the LDR pin. So if the value of the LDR is less than 200, so we mean that it's a dark. So we should turn on the LED. And if the value is greater than that, then no need to turn on the LED. So that's why LED is off. Okay, so this is the code. analog. So we need to put here LDR. Okay. So we are reading that to LDR status. We are comparing, and yes, we are printing that value. Copy paste error. Returns. Otherwise, we'll write our code. So what are the two functions we have in void setup, right? Yeah. So what we are doing, we are initializing the nodes. So what are the two pins we are using? So one is input pin and another one is output pin. So which LED pin? LED pin number 13. The LED pin 14 is output pin, and in I have connected A1, but I have anything else. This is input pin. Okay. So next is which function? Void. So what we are reading here, we are reading the digital analog read, analog read for the pin number A0, A1. Okay. So if the value is less than or equal to 200, so we are turning on the LED. So what is how to write? Digital, right? Pin number. So pin number is 13, 5. So it will be below the LED. If you want delay, you can give delay. So there's a delay of 1 second. Then else we are writing digital comma low. Yeah. So code is running. So how to vary the light intensity? Again, you click on the sensor and then you can vary the value. So you can see that if the value becomes greater than 200, the LED is off. So you can see the value. So I have not printed here. So you can use serial dot print, right? Serial. So print lm. Should prints. Okay, we are not initialized that serial dot begin. Yeah, you can see that values 20. So you can and then yeah. So the values are printing. So first you need to initialize that function, that is serial dot begin 96,000. So then you can use this serial dot printing. So you can vary this light intensity. Yeah. So what's happening? So if the light intensity is less than 200, so I'm now the LED is glowing. So you can see that if the value is less than 200, the LED is glowing. Okay. So you can use this for making the bulb to turn off if there is more light intensity. So this is the usage of the LDR sensor. Okay, so the next sensor is ultrasonic sensor. I think so. This sensor I will cover in the next class. Okay. What is left out is ultrasonic sensor, then the LCD display, and another one is DC motor. Okay, so the DC motor, ultrasonic, and this LCD display I will explain tomorrow. And also tomorrow I have asked one of my students to show the demo using hardware. So he has the hardware Arduino and some sensors. So he'll be giving the demo. Okay, and as I told, there is a tilt symbol, no? So I told that I will be explaining that with an sensor. So that is, I can explain that I will explain with the DC motor. Okay. So, so that time I will explain that. So now I have prepared a quiz. So please answer that quiz, and also have created a form for feedback. So please complete. I'll share that form link. So this is for quiz. So this link is for quiz. Okay. And feedback link I will just share in the WhatsApp group. Okay. Please complete it. Okay. Well, thanks for joining. So we'll see you in the next tomorrow session. So complete the quiz.